Good evening, ladies and gentlemen, and welcome to our Highland Branch Royal Aeronautical Society webinar on Towards Zero Carbon Aviation in the Highlands and Islands. My name is Kirsty, and on behalf of the Highland Branch Committee, I'm delighted to welcome back those who have watched our previous webinars, society members, friends of the branch, and also those joining us for the first time. It's always great to know who we have joining us, so please use the chat to introduce yourself and tell us where you are from. If you can keep yourself muted during the presentation, that would be very much appreciated and ensure a smooth delivery of the webinar. Throughout tonight's presentation, I invite you to type in questions in the chat, which will then be answered at the end. Or alternatively, at the end during the Q&A session, you can raise your hand using the webinar's function. After, I will ask you to unmute your microphone and turn on your video if you wish to interact with Andrew and ask him yourself. We are pleased to welcome an eminent speaker tonight, Professor of Engineering from the University of the Highlands and Islands and Chief Engineer for Ampere in the United Kingdom. Ladies and gentlemen, without further ado, it gives me great pleasure to welcome Professor Andrew Rae.
Thank you, Kirsty. Thank you for that introduction, and it's a pleasure to be here. It's my second time presenting to the Highland branch, and it's always a pleasure to do so. Thank you all for joining us this evening, and thank you for your time, and hopefully it'll be worth your while once we get to the end of this. So I'm going to try and attempt to share my screen. So hopefully you can see the site logo there. Kirsty, can you confirm that for me?
Yes, we're all good. Grand.
Okay. So the main topic of my talk this evening rather, is the SATE project, the Sustainable Aviation Test Environment. But I'm going to focus also on Ampere's contribution to that, which is the hybrid electric Cessna 337 that flew between Wick and Orkney earlier in the summer. So, as I mentioned, it's about the Sustainable Aviation Test Environment, and it's partly funded by the Industrial Strategy Fund and the UK Research and Innovation part of UK government, which also funds Innovate UK and the Knowledge Transfer Network. So I wanted to cover 4 different things this evening. I'm going to get that right in a minute. Firstly, the Future Flight Challenge, which is the funding mechanism that allowed the SATE project to be set up, and then concentrate on a description of the Sustainable Aviation Test Environment itself. Then I'll focus a little more detail on Ampere's hybrid electric aircraft, and then a little segue into a personal connection. So firstly, the Future Flight Challenge. So I hope most of us joining this call will know that aviation's part in the fight against climate change is crucial. It's a big contributor to climate change, and it needs to change. So the status quo is not good enough, and doing nothing is not an option if we want to maintain air travel at all. So there's been a variety of strategic visions of what the future of aviation might look like. We have the European Clean Aviation Project, which follows on from the previous Clean Sky programs. In the UK, we have the Jet Zero consultation, which looks at net zero aviation strategy. Then more locally in Scotland, we have the Scottish Government's Green Deal, which within it includes a commitment to put the Highlands and Islands on a path to becoming a net zero aviation region by 2040. And so there's a mandate there on Highlands and Islands airports limited to commit to zero emissions from its airports. And in that report, they mentioned that we would start low or zero emission flights in 2021, and I'm proud to say we did so. So the UKRI Future Flight Challenge was set up to look at ways of encouraging the development and adoption of alternative types of flight. So there are some perhaps slightly dystopian views, as in this picture here, of lots of drones flying around the middle of the city, and that's a long way off, and a lot of things have got to be sorted before that happens. But it's one of the challenges to academia and to industry to lay the path for the technology to achieve these things safely and reliably. So the Future Flight Challenge is concentrating on 3 types of aircraft. So one is what it calls drones, but that includes all types of uncrewed air vehicles. And then what's called now advanced air mobility, but it's probably better known as air taxis. And then probably more of use to us in this region is regional air mobility, which in this instance is defined as 10 plus person aircraft, but obviously the islanders that fly in Orkney and Shetland are 9 passengers, so that there's kind of a grey area on the demarcation there. So the whole point of this is predicated on use cases. It's a user market rather than a technology push. So it's identified a series of use cases. There's 8 shown in this picture. I'll just concentrate on a couple, which are the rapid airport transfer, cargo delivery, drone delivery, and intracity journey. But for our region, a lot of the use case requirement is for sub-regional and rural transport. So how to get between the islands, how to get from the islands to the mainland, how to get from the cities through to our smaller littoral communities. There's quite a timeline through to in service of some of these aircraft by 2030, and the first phase of future flight, the phase we're currently in now, what's called phase 2, is the demonstration phase, which will end in 2024, and the current project, the development phase, is coming to an end in the middle of next year. So there's a whole route map, a pathway through to seeing some of these technologies become commonplace in the market. So that's the background of the Future Flight Challenge. Now I'd like to concentrate on this project's contribution to that greater challenge, which, as I mentioned, is a Sustainable Aviation Test Environment. So the funding level is about £125 million from UK government, which is matched by £175 million from industry. And with Highlands and Islands Airports as the lead partner, the industrial partner, we assembled quite a wide-ranging consortium, and I'll go into more details of some of that in a minute. So we have a mixture of industry, of research centres, of academia, and government bodies as well. So the state objective was to create the UK's first low carbon aviation test centre embedded within an operational base, so Kirkwall Airport in Orkney, as a way to test and evaluate some of these emerging technologies in a realistic environment, and not just an operational environment, an environment which is subject to the vagaries of the weather in the way that some other test environments are not. So if it works here, it can work most places. So what we call the technology partners within the programme are looking at a variety of technologies. So Ampere, which I'll describe more later, is looking at a hybrid electric aircraft. ZeroAvia have a hydrogen-based aircraft platform. Loganair are looking at sustainable aviation fuels within their fleet. And then we have a couple of UAVs. The biggest one at the bottom of the middle of the picture there is the Windracer's UAV, which has been in the headlines recently, which is capable of carrying a 100 kilogram payload over a distance of up to 1,000 kilometers. So it's a very capable airplane. And then at the other end of the scale, there's Flarebright's little drone, which uses artificial intelligence as a guidance system to learn how best to get to somewhere, and can be used for precision deliveries. But it's not all about these platforms, it's about the airport infrastructure that's needed to support them. So if you've got a hydrogen aircraft, how do you refuel it alongside kerosene or avgas? And then if you have autonomous operations, you need a resilient and full coverage digital infrastructure. And the socio-economic benefit of all of this, hopefully, is improved regional connections, bringing inward investment and improving the local supply chain. But the end goal is contributing to a net zero aviation region by 2040. So as I said, the test centre is based, excuse me, is based at Kirkwall Airport, which is a busy multi-use operational airfield. In 2019, before COVID struck, it handled nearly 200,000 passengers and 14,500 aircraft movements. And the Orkney Islands itself is home to a variety of real-world use cases, which the current capability of aircraft would be able to be tested against, which, as I mentioned, include the intra-island services, the island mainland services, and UAV logistics and medical type activities, including deliveries of Royal Mail, again, which you'll have seen recently, those of you who have seen the news from Orkney. So some of the innovative aspects of the Kirkwall test environment are that because it's an operational environment, it has to adhere to all of the safety and regulatory policies that pertain to an operating airport. All of the aircraft that operate there have to comply with regulations and safety thresholds. And it's fair to say that a lot of what we're trying to do now isn't properly covered by some of these regulations and policy. So a large activity within the project is to create a roadmap of what needs to change to be able to enable these things to operate properly, but also safely. And one of the benefits of decarbonising aviation is if you do it properly, you end up with lower cost operations and possibly new ways of operating a route network. You might be able to connect destinations that are not currently connected. And as I mentioned, the whole test environment covers both the physical, the digital, and the operational airport infrastructure that we need. And I have to say that Highlands Islands airports have been exemplary in leading the way on this. And I think I noticed that David Holden is on the call, and David had to step down recently as a project manager, has steered a very firm hand on the tiller of this ship as we went forward. And it's good to see you again, David, and my best wishes to you. So the infrastructure side, probably the most obvious one for those of you who are in and around Kirkwall, is the large new hangar at Kirkwall Airport. It's not just a hangar, it's office space, it's access to the aprons and taxiway, and provides a full home for some of the technologies that we've been testing. And wind racers who have been flying recently in Orkney have been using that facility. So just a couple of headlines here that recently. So Boeing Ampere's Trumpet, we had the first electric powered aircraft flights between Wick and Kirkwall back in the early summer. And then more recently, the use of wind racers drones to deliver Royal Mail between Kirkwall and North Ronaldsay. And the picture at the top there is wind racers aircraft at North Ronaldsay on a typically beautiful Orkney day. So that's the general project of the Sustainable Aviation Test Environment. I want to concentrate now a bit more on the details of Ampere's hybrid electric aircraft, which flew earlier in the summer. So this is the aircraft. It's a modified Cessna 337. The 337 was chosen because it's a twin-engined aircraft, so it offers twin-engine reliability and safety, but both engines are in line. So if one engine were to fail, it doesn't alter the direction in which the thrust is acting, and you don't get the yawing moment that you would from a conventional side-by-side twin. So it's a very safe way, or the safest way of doing this type of investigation. So in the aircraft that flew earlier in the year, the front engine has been replaced by an electric motor, and that replaced a previous incarnation where the rear engine had been replaced by the electric motor. So this is an example, a schematic of the rear engine layout. So within there, you've got the propeller at the back, then the two black donuts are the electric motors. The green box is an inverter. We've got cooling for that, and then we have the high voltage cabling and the thermal management system, and connection through to the battery and the battery management system. So it takes up much less room than a conventional internal combustion engine, and it weighs a lot less. Obviously the battery weighs a bit more than the combined mass, but we've got lots of volume to play with inside a conventional engine housing. This is a picture of the front engine, front electric motor layout, picture taken down at Exeter when we flew down there with a few of my Ampere colleagues. And I think the one on the right, Pauline, is on the call as well, so hello, Pauline. So the layout is shown on the left-hand side there. This time we've got the single larger electric motor, we've got the inverter and the cooling system for the inverter as well. As I said, this weighs a lot less than the conventional motor, engine, and you can see from the engine bay at the front there, it takes up a lot less room. The weight is a problem because if we didn't do anything about it, we'd upset the weight and balance of the aircraft, so we had to add some ballast in the nose, which adds more weight and reduces the payload that we could use on this experimental aircraft. So the route to flying in Orkney and down in the southwest was not a short one. It was done in a sequential and building up confidence in the capability of the aircraft and its safety. So the baseline aircraft was bought and modified. So the super upgrade is an uprated wing arrangement. It's got a different leading edge on the wing and other extra bits in it. And then on the right-hand side of the cockpit picture there, you can see where what looks like an iPad has been added that looks after the electric motor and the battery management system and displays the information to the pilot. So I said it was a sequential build-up of technology and confidence. So it starts with what we call a copper bird, which is the electrical system testing through to an iron bird, which is just the mechanical system mated to the copper bird, and then the proper aircraft itself, which went through high-speed taxiing, then short flights into full flight demonstration, but I'll cover that in a bit more detail now. So the copper bird is looking at the electrical system in isolation. So it's the connecting the battery to the battery management system, the motor to the inverter, and testing all these components both individually and as various build-ups of a system to make sure they all function properly and how we expect them to before they go in an aircraft. And then once that's been completed, we go to what's called an iron bird. So this is a crash survived structure. It's never going to fly again, but we were able to integrate all of the systems within a representative airframe to make sure that that integration doesn't inhibit any of the functionality that was shown on the copper bird. So that a lot of that includes the integration is involved in effectively shoehorning that system into the available space within the airframe, which affects things like the space available for cooling and other operational requirements. And a lot of the effort here is to understand what the pilot needs to see, how best to present it, and how to integrate it into the cockpit environment. So from a pilot's point of view, we want to give him the important information in a way that he can easily read it and understand it, and especially to be able to react if something goes wrong. As part of this process, Ampere partnered with a couple of flight test pilots from Wasabi Flight Test, Justin and Elliot, and parts of this presentation were taken from one that Justin presented to the US Society of Experimental Test Pilots. So the timeline of our project is shown on the left hand there. So we had the component and ground testing, and then the baseline flight test, so evaluating an unmodified aircraft to give us some information about that, and then implementing the hybrid electric system, and then on the back of that, updating all of the manuals and the procedures that you need to have in place to brief the pilot and the ground crew to make sure that the aircraft is operated safely. So a normal flight manual will include how to start up the engine, it'll have a checklist, it'll have emergency procedures. So all these had to be written and updated for the modified aircraft. And then the plan was to take that modified aircraft and evaluate it on commercial route demonstrations. So the aircraft in its current form first flew in October in California. It flew from Camarillo to Hayward, and in process created a record flight. It did 24 flights over 28 days, a total of 33.5 flight hours. So to paraphrase Tony Ritchie, we did know the way to Camarillo, and there was no fault with the aircraft at all. It was 100% dispatch reliability. And that's a video of the aircraft, hopefully you can see, flying over the California coastline. So once that confidence had been built, Ampere had partnered with an airline in Hawaii called Mokulele Airlines, and the aircraft was taken across to Hawaii and did another 22 flights on an example of one of Mokulele Airlines' internal routes. So it's the first time ever that a hybrid electric aircraft had been used on a representative regional route. And we were able to gather quite a lot of flight test data to understand what the fuel saving is on the aircraft. And you can see the figures on the top left there that got an average of about 30% fuel burn savings by using the electric motor in conjunction with the conventional combustion engine at the back. But again, we had 100% dispatch reliability, so nothing went wrong with the aircraft, and a total of just under 24 hours of flying. So there's some interesting backdrops in Hawaii, and you can notice that the aircraft is flying over water, which is one of the certification issues that affects an electric aircraft, and I'll come on to that in more detail next. So in the US, Ampere had acquired a Federal Aviation Authority experimental approval for the aircraft, initially for research and development, which was extended to market survey. So the geographical bounds of the approval were slowly extended as the FAA became more happy with the safety and the operation of the aircraft. So to bring the aircraft to the UK, we had to get a UK approval through the Civil Aviation Authority. And within the Future Flight Challenge project, the CAA is engaged through its Innovation Sandbox, which up until recently, primarily, I guess, it's been looking at things like drone operations and how to cope with new technologies there. But each and every project within Future Flight Challenge had to submit a concept of operations, a CONOPS, to the CAA, identifying what they'd like to do and how they'd like to do it. And the sandbox has a 6-step process. So you engage initially and provide the CONOPS so they can understand what you want to do. They then help you plan the testing, take the learning from that and feedback into it. So after our flights this summer, we've been giving feedback into the CAA about how the process might be changing in the future. But at the end of this is really looking for approval for the experimental aircraft, but looking forward to what's called a supplementary type certificate. So if Ampere's aircraft were to become a production model, we'd need a supplementary type certificate to be able to do that. So when we submitted the CONOPS to the CAA, they came back with 3 possible approval routes, which we're going to try and sequence. The first of them was to seek what's called a foreign aircraft exemption. So effectively take the FAA's approval, make sure that that's appropriate, and then give us a UK approval based on the FAA's approval. If that wasn't appropriate, then we'd have to go under what's called E conditions, which is the experimental equivalent in the UK. However, that probably wouldn't have been appropriate because there's a 2,000 kilogram weight limit under E conditions, and Ampaire Cessna 337 weighs 2,200 kilograms. So it's too heavy for E conditions, which meant we would have had to go for a permit to fly, which is a much more arduous and long-winded process. So we were very happy when the CAA gave us an approval based under the foreign aircraft exemption. That had some consequences though, because it meant that the CAA did not itself approve any continuing airworthiness approval of the aircraft. It was all had to be done under the FAA airworthiness approval. And one of the consequences of that was that the aircrew had to be FAA licensed and the maintenance engineer had to be FAA licensed. So traditional UK or European licenses wouldn't have been accepted. It had to be American FAA licensed personnel, which meant that the pilots and the engineer had to be brought across from the US. I show that the head of the permission, the approval we got from the CAA. Finally, if you notice the date there, it's the 3rd of August this year. Bear that in mind with the next slide. So the aircraft was dismantled in Los Angeles, put in a container and shipped across to Europe initially, and then up to Grangemouth, where it arrived on the 17th of July. It then went on the back of a road transport trailer and arrived in Wick on the 20th of July. And we were hosted at Wick both by Highlands and Highlands Airports Limited, but also by NHV Helicopters, who loaned us their hangar to put the aircraft back together again. And we reassembled the aircraft, and then we were able to make our first checkout flight on the 4th of August. So the aircraft was ready one day after we got the approval. So the approval process was at risk of holding us up. And then once the pilot was happy that the aircraft was okay, it survived the journey and was functioning correctly, we had to wait for a decent day of weather, and the aircraft first arrived in Kirkwall on the 6th of August. So there's a couple of pictures there of its first arrival. Thanks to Neil Thane at Kirkwall Airport for providing those. And the picture on the right is a still from a video taken from one of the air traffic controllers at Kirkwall on its first takeoff back from Kirkwall to Wick. So it's quite a surreal moment between Highlands Airports and myself. We'd been contemplating the SAIT project since November, December 2019. So after the best part of 2 years, it was quite surreal to see a tangible evidence of the project coming to fruition. So further flights took place between Wick and Kirkwall. We planned to do more flights, but they were curtailed by the weather. But if you come to a harsh weather test environment, that's kind of what you expect. And on the right there is a picture from the aircraft where it flew over Kirkwall but didn't land and returned straight to Wick. So once the flying in Orkney had completed, Ampere is part of another future flight challenge project called 20, which is based in the southwest and involved Exeter and Ukri airports, as well as some other local authorities and airlines down there. So the aircraft was due to leave Wick and head for Exeter. Unfortunately, the aircraft's standard transponder failed en route, and we had to drop into Perth to get that fixed. And our thanks very much to ACS at Perth Airport for helping us out, both with replacing the transponder and accommodating the aircraft while we waited for the weather to clear. But once that had happened, we were able to break our own record, and the aircraft flew the 418 nautical miles non-stop from Perth to Exeter, where we did some more market survey flights. So Wick is known as John O'Groats Airport, so we flew literally from Land's End to John O'Groats. And on the right-hand side, the top picture is a photograph of the aircraft at Land's End, and then en route back to Exeter, and then on the approach to Exeter Airport. So finally, a little bit of connection. I noticed my father's on the call as well, so there's 3 generations of RAeS represented on this presentation. So this project resonates significantly with me because my grandfather John Rae was a senior pilot for Highland Airways, based in Kirkwall in the 1930s. So picture him there with the Havilland Dragon, based at Wydford Airfield, which was the old airfield before the new site up on the hill. So the baby on the right is my uncle, as in the pram, and you can see St Magnus Cathedral, for those of you who know Kirkwall, in the background on a snowy day. And then one of the incidents that was quite famous at the time was a crash landing in Rassy, where the aircraft was trying to land in a headwind, and the headwind stopped, and managed to drop the aircraft into some trees, which, if you know Orkney, there aren't that many of. But the aircraft, everybody got off the aircraft was recovered, and it was flying again 3 days later. Prior to working at Highland Airways, he flew across in Renfrew near Glasgow in Midland Scottish Air Ferries, and that caravan on the left in front of the hangar is my grandfather's first marital home. So the what looks like a beehive outside the caravan is a weather station. So my grandmother must have been a fairly understanding woman at the time. And just for those of you interested in airplanes, on the left is a airspeed ferry. Interesting engine arrangement that the lower 2 engines are inverted. And on the right hand side are, from left to right, my grandfather, Winifred Drinkwater and Jimmy Orrell. One of the things that they needed to be in that time was a licensed engineer as well, because if you were the lone pilot and you had an aircraft issue on one of the islands or remotely, it was you that fixed it. So Winnie Drinkwater became a licensed engineer at the tender age of 17 and was an excellent pilot. And Jimmy Orrell on the right hand side there later became a test pilot for Avro and flew the first flight on the Avro Lancaster. So thank you very much for your attention. That's me. I hope that's been of use to you.
Thank you very much, Andrew, for that fantastic presentation, giving us all an insight in how Ampere is developing electric aircraft that are safe, clean, quiet, and less costly. Now we will go on to our Q&A session. So if you have any questions at all, please either type them into the chat or raise your hand and we will invite you to speak. Could Finlay Asher, would you like to go ahead?
Hey there, thanks for that. I was just wondering, when you showed the difference in fuel consumption, whether that was is that based against like the exact same aircraft with an internal combustion engine, or was it like versus a different aircraft flying the same route? Thanks. Does that make sense?
It does, yeah. That 30% figure is against the same aircraft just using their air engine. It's very difficult to get like-for-like comparisons, but clearly and what I should say is that we use the electric motor to assist the takeoff and the climb, so that the max power part of it, then we almost shut down the electric engine and just cruise on the single engine. So the fuel consumption is decreased for 2 reasons. One, you're using the electric motor to assist you taking off, and then you can throttle back on the engine that's almost redundant at that point, and the internal combustion engine can take over. So, and then one thing to say is that this configuration isn't optimized. If we were to design from the clean sheet of paper design, that fuel efficiency would go up.
Thank you.
I think Charles Coulson, would you like to go ahead?
Can you hear me?
Yes.
Good. In terms of, volumetrically, obviously the electric motor installation, both fore and aft, takes up very much less space. The batteries presumably are in that cubby underneath the what looks like a pannier. In terms of all up weight, how does that present in terms of a reciprocating engine installation?
So the weight of the battery is key, and it does affect the payload of that configuration. But you would normally size the payload, the size of the battery for the mission requirement. So it would change depending on what you wanted the aircraft to do, and you'd optimize the size of the battery, the size of the internal combustion engine, and the size of the motor to match whatever mission you were trying to fly. But at the moment, the power density of batteries means that there is a payload penalty on most applications.
That's going to be something that has to be addressed, though, is it not?
It is, and the other factor is that although electric propulsion is attractive, batteries aren't a silver bullet. They contain materials that are rare. They're hard to recycle, and so maybe something like a change in battery chemistry would enable us to do things more sustainably and more efficiently.
Okay, yeah. Work in progress.
Oh, absolutely, and these are the first steps on the road to a solution. But the full solution is 5 to 10 years away at least.
Okay. Thank you.
So we have one question from the audience, and he's asking, how will we provide the energy source if it's going to be all electric aircraft? And then he's following that up by saying, or is there anywhere in the flight stages we can use reverse thrust to generate energy or charge up the battery packs?
Good question. There are a variety of solutions to a hybrid electric. The one we've got at the moment, where the electric motor is completely separate to the internal combustion, is called a parallel system. There is a series version where you have a generator motor that recharges the battery in flight. And again, the optimum architecture and the optimum sizing depends on the mission requirement. We have thought about using the propeller as a generator in flight, but to generate that energy, you cause drag. And so it's a case of balancing the extra power you would need to overcome the drag versus the extra generation you get from it. But for example, when you're on approach to land, you want the aircraft to slow down, so drag is good. So you might contemplate using the propeller as a generator there to provide some braking for the aircraft. Passengers don't tend to get off unless the aircraft stops, so it's useful to help brake the aircraft, and especially on some of the airfields in Orkney and Shetland, an extra bit of braking might be useful. And also, if you don't have to use the wheel brakes, it's one less bit of maintenance that you have to contemplate.
Thank you, Andrew. I think that answers our question. Do we have any more?
I have like further question. If it's hi, I'm Anup. I just finished my master's from Concordia. So as my master's program for the last final year project, we were working on this similar concept like zero carbon emission. We designed all electric aircraft using optimization battery of graphene material. As you just mentioned, like we can change the energy density of the battery material and we can go for that. But as a parallel thought, is there any other development in the industry that is like, what if we are not changing the engine itself and still we keep on using fossil fuels and still optimize the performance, like not having any carbon emission? Like, I don't know. if my question is making sense, or but I don't know what I'm trying to say, but do you understand? Like,
Well, if you don't know what you're trying to say, it's hard for me to understand what you're trying to say. But
now my question is like, if we are using traditional aircraft's engine, and still we are not getting this carbon emission. Like, what if this carbon emission is retrieved back and used again as a force? You know,
if I
like
think
a
I understand,
perpetual system. You know.
well, it's a nice idea. I'm skeptical about a perpetual system. I mean, if you're burning fossil fuels, even if you're burning sustainable aviation fuel, you still emit particulates and other emissions that, although the fuel is greener, you're still affecting things like cloud formation and other things. So sustainable aviation fuel will help, but it's not an answer. I mean, the trouble is that there is no silver bullet here. There's always a
particulate that we cannot refine. Yeah. So there isn't any technology available, like, or there isn't any company working on those extruders that we are not required, and we can use it again in our system anyway to, thrust back.
I'm not quite sure I know what you mean there. Sorry.
Like those particulates that you are talking about, that we don't want to be formed in the first place, but due to our traditional engine formations, it's keep on manufacturing, like it's keep on generating that's what affect the environment in the first place. So what I'm trying to tell you is, like, what if those particulates are being used as a force to again thrust back,
so you
like a extension of an engine with extra thrust available, using what we call less amount of energy that we require. Basically, I'm trying to enhance the performance of the engine using less fuel.
Okay, right. I think that the mass of the particulates is small, so the momentum is going to be small, so the energy available is going to be small. So I think, yeah, I mean, to harness that, you'd need something quite special to do it, and it would have weight, which adds weight to the aircraft, which probably kills any benefit you'd have got from that.
Okay, I understand.
Okay, we have another question from Chris Beattie.
Hi, Andrew. Just a question about the batteries that you're using, and didn't quite catch the battery technology that you're using. But did you have any difficulties with the hazards that carrying large batteries of that type may pose, or the hazards that are inherent with, for instance, lithium batteries?
So the batteries are lithium-ion batteries, and they come from an electric motorcycle. So they've gone through a transportation safety program, but we worked very closely with Highlands and Islands Airport's fire service to cover things like training. So there are two scenarios. One is the battery catches fire. One is the conventional fuel catches fire, and what you do in each case. And one of the things that the CAA were concerned about was some of the emergency procedures around that. As someone has previously mentioned, the battery is carried in an aeroshell underneath the fuselage. So if you had an undercarriage failure, it would be the first thing that hit the ground. So a lot of the emergency procedures and protocols were constructed to prevent that kind of eventuality.
Thanks.
And I'd say that in addition, Hyle were great in contacting the fire brigades around Scotland underneath the flight path. As we've seen recently, it's possible that if you had a problem, the aircraft wouldn't land back at an airfield, it would land off airfield. And the first people to get there would be the local fire brigade, not the airport fire brigade. So that the learning that Hyle acquired was transmitted to the fire brigades around Scotland, just in case we came down somewhere we didn't intend to.
just as a follow-up, does the mixture of, because obviously it's quite unusual to have the large lithium-ion batteries and lots of aviation fuel, does that cause like a paradox in how the emergency services will tackle that fire in terms of understanding which is the most immediate threat?
That was part of the training, was assessing which was the priority, and obviously which protocol you followed. So as you suggest, the way to cope with a battery fire is different to a kerosene avgas fire, and it's understanding the consequences of the choice of action, as well as the choice of action you should take in the first place.
Thank you, Andrew.
Okay.
We still have time for a few more questions, so now is your chance if you want to type it in or go ahead and ask Andrew yourself. Paul?
Yeah, hi, Andrew. Thanks very much for the insight into the history of the generations of your family in the aviation sector. I was just wondering, where do you see this project a generation or two down the line?
Good question. I would love to see net zero operations, whether that is fully electric aircraft, fully hydrogen aircraft, or whether it's still hybrid. I think certainly short haul and long haul flights are a difficult challenge to crack, but I think sub-regional and regional flying could well look very, very different within the next generation. And the capability of autonomous aircraft now is incredible. We just need to understand how best to use them and keep people safe while they're being used. The things that wind races have been doing in Orkney could genuinely be life-changing. And if we add some of the medical exercise that they've been doing down on the south coast and across the Scilly Islands, it could change the way that we do some of our healthcare provision, as well as some of the more mundane logistics.
Would the Highland branch member like to ask their question?
Come on, Kirsty, you know it's me hiding behind the account. Andrew, what I was wondering with this was, you've at the moment got a hybrid. It's a hybrid aircraft at the moment. Is this demonstrating actually there is a possible anything but the possibility of a retrofit to the existing fleets of aircraft, where actually you're avoiding the upfront costs of a brand new all electric aircraft, and instead you're able to retrofit your existing fleet into electric to start offsetting those costs? It's not the immediate step to zero carbon, but it's cutting the carbon levels.
Yeah, it's a good question. Ampere's business plan predominantly is the retrofit market. So taking existing airframes and introducing a hybrid system, and that's what you need, the supplementary type certificate that I mentioned. And so in the US, they're looking at the Cessna Caravan. In the UK, we'd be looking at another airframe in the next phase of the project. To take a clean sheet of paper design from conceptual through to type certificate is a long process and a very costly process, and it will happen. But in the meantime, you've got to take these smaller steps to understand the capabilities and the challenges involved. And I think for those of you that saw Ampere's aircraft on the cover of Aviation Week, the title they used was a hybrid bridge to the future. So it is that first couple of steps on a longer journey.
All right, thank you.
James Cochrane.
Yeah, Andrew, I couldn't keep quiet any longer. So I got a couple of questions actually. One is, I guess that really we're going to hopefully ride on the back of solid state lithium battery technology to get us the efficiency we really need, and also gather the safety, or get the safety by actually breaking that barrier or making sure the barrier between the cathode and the anode in the battery is safe. So, you know, because your 30% sort of fuel efficiency really needs to be closer to 50, 60% to make it viable, I would have thought.
Yeah, it depends on the operator's requirement, but the trick at the moment is the infringement on the payload, and that might be solved by future battery chemistries, but all of the ones that have been talked about are very low TRL, and it will take a long time to get them to anywhere like an approved system for an aircraft. So it's yeah, I think I mean, the other thing to bear in mind is that the business model for these types of aircraft will be different. So if you took an Islander that Loganair operate in Orkney and could give them an electric one tomorrow, they wouldn't and they shouldn't operate it in the same way they would operate an internal combustion engine version of it, because the business model, the costs, the efficiencies will be different, and you could do things with it that you couldn't currently do.
Yeah, understand. I mean, yeah, I think puddle jumpers are perfect for this environment, but you know, long haul gets a little bit more complicated in terms of the business model and density of fuel. I mean, one of the things that you have, you know, if you took a lorry, you know, a 40-ton lorry, you need 20% of it needs to be a battery to have the same performance, right? So it's the same maths but I think if we get solid state batteries, they can actually have an energy concentration that's 3 times the amount of current battery technology. But yeah, you're right. But that's always been apparently 10 years off. We talk about net zero, but of course net zero is, we talk about it in terms of operating net zero, but the embedded carbon in a battery car or aircraft is actually quite huge compared to a normal aircraft. So we tend to sort of like use net zero in subcontext, really, when actually you know, it's very difficult to actually offset any carbon gains you get from having battery technology. Would you not agree with that?
Absolutely. As I said earlier, that there is no silver bullet, that there's no perfect solution, and there is going to be an element of greenwashing around this for some years to come. I mean, sustainable aviation fuel has been touted as a solution for long haul, but as I said, that even aside from where you get the feedstock from and the power you need to crack it, the fact remains that you're still chucking stuff out into the atmosphere that causes nasty things to happen, and so it's hard.
By the way, I'm not having a go. I'm just basically stating some facts, right? But because you're right at the beginning of your presentation, you said the answer is not to do nothing, right? We can't just sit around and do nothing, so we have to do something. So yeah, that's the important thing.
And I quite expect my successors to look at what we did and laugh, but we've done something.
Thank you.
Okay, thanks, Tim.
Do we have any more final questions?
There's one in the chat, actually.
Thank you. So Pete's asking, very interesting, is there much development looking at hydrogen PEM fuel cells for aircraft instead of batteries?
So one of our partners is ZeroAvia, who are using hydrogen fuel cells to propel their aircraft. They were due to fly in Orkney this year, and unfortunately they had an incident down at Cranfield, near Cranfield, so they weren't able to participate. They're still working in the project. They've now switched focus to a 19-seat aircraft, so the sort of size of a twin otter. It's actually only a 228. Hopefully they'll be participating in the next phase of this project in Orkney, which starts sort of Easter time next year.
Great, thank you. Last call before we finish up. If that's everything, that is the end of our Q&A session. Once again, thanks to our speaker, Andrew, and for our audience for getting involved and asking some really great questions tonight. And of course, to the production team who have been busy behind the scenes running this event for you all. You will be able to watch this talk again using the link which you used to join the event, and a copy will also be posted to the Royal Aeronautical Society's YouTube channel. If you'd like to stay informed about Highland branch activities, please do join our Facebook and LinkedIn groups. You'll find links for these in the chat. I look forward to welcoming you to future Highland branch activities. Our next event is going to be with Ruth Mallers-Rae on the airspace innovation, the role of role models. That's going to be on Thursday, the 11th of November, so be sure to add that into your diaries. Once again, thank you so much for joining us this evening. I truly hope you enjoyed the webinar as much as I did. Good night.